Hey everyone, Blake here. I am doing another little video on some of the machine learning stuff that I've been up to. So previously we talked about a very simple robot. It had 2 degrees of freedom. I moved on to a more complex robot. I had originally planned to have it at 3 degrees of freedom, and then I thought about it more and I went into my modeling tool, which in this case was Google Blocks, and I started drawing it up. And I did one with 4 degrees of freedom, and so I was going to have a rotate, bend, 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 and then I realized that this third bend wasn't really that much help without a rotate there as well, because being able to bend like this is okay, but being able to bend like that is much better. So I ended up going all the way to 5 degrees of freedom on this robot. So we're going from 2 to 5, so that's a very different problem domain space for these machine learning algorithms to learn in. Again, the structure is very similar, so you can see my new model here. So again, I just drew this up quickly in Google Blocks, and I've shared that. So if anybody wants the link, leave a comment, and I'll post the link over to the Google Blocks so that you can get this very rudimentary 5 degree of freedom robot. It's not a perfect model. I had to go into Blender and change the origin of the different joints so that it went into Unity okay. And this is also going to be up on my GitHub, so you'll be able to grab this. So as you see, we have a structure with a fairly significant hierarchy, right? So we have the arm, it has the shoulder rotation, shoulder bend. The upper arm was just the pipe there. And then an elbow bend, lower arm, again, just the pipe, wrist rotate, bend, wrist. And then this wrist mesh was because of a hierarchy issue. I thought I wanted it to rotate first and then rotate or bend. And then it turned out I really wanted the rotate and the bend to happen at the same time. So I had to move around this portion of the mesh. But it does okay. And then the hand. Now the only problem is, as you'll see here, for the hand to bend correctly at the wrist, the origin has to be a little lower, and therefore inside the hand there's just this hit center, which is a game object with stuff turned off. And the idea is we just have a transform in the center that it's easy to calculate distances from, so that I can tell whether or not the hand has hit the ball, because as we learned last time, using colliders isn't always the best thing to do in this case. What else we have? We just have, camera, a light. Score is pretty much the same. The target is a little different. The target has reference to the game manager, and then also to the hit center. So the target is actually doing these distance checks, and then has a thing here where we can adjust the touch distance. In this case, it's a quarter of a unit. That seemed to work well. And again, this is an entirely encapsulated environment so that I can use my environment builder and make multiples of it. Now, previously, I've been using my keyboard to control the robot. With 5 degrees of freedom, that becomes really hard. And to have enough gradations of movement to hit targets accurately, plus also just from a mental standpoint, controlling it becomes really hard. It's hard to control no matter what. With 5 degrees of freedom, these robots are actually quite challenging. But in this case, I've gone over to the game controller. So I have my game controller here. So on the left stick, it controls the major bend back and forth as well as rotation. So those two together kind of do what the previous robot did. Now, as you'll see, this target is inside the area, and I don't want it to just have it where it if anything touches it, you win. I want it to be very purposefully the hand, the tool portion, has to touch it in order to win. So then we have our next level of bend. So on the right joystick, we have the elbow bend, and then we also have the wrist rotate, and then on the triggers, I have the last and final bend. And so it feels a lot of fun to control this. It's really kind of neat to be able to do it. You can do some neat things with it. It feels good. When I designed it, I also used the golden ratio to roughly proportion out the parts so that it looks a lot like an actual creature that might exist. It is the kind of creature arm, it really is based off of like a human arm kind of thing. And so there's a lot of control here, but it also looks very, well, I'm not going to say natural, but it certainly looks more natural than the 2-degree freedom robot. Let's go for that. So, as you can see, I'm getting around. I have been able to grab every target in this space thus far. I haven't had any problems in any of my testing, but it is very important that in your testing you be able to do this, so that you know that the game at least has, or the machine learning algorithm at least has a chance of being able to grab stuff. You can, in theory, grab things below, but I haven't really bothered with that. So everything, all of the targets are spawning on the half-unit hemisphere, right? Or I'm sorry, on a unit hemisphere. The range is actually 0.5 meter to 2 meters because there is a case like right down by here, the actual shoulder joint. This wrist can't reach all the way back to its shoulder. So I did make sure that nothing was spawning like super close to this, but everything that is within that 0.5 meter to 2 meter range, I have been able to successfully get in some amount of time. Now you'll notice that I have also, while I'm under human control, have turned off the time limit because even being the author of this, I am not that good at it. It is a very challenging little problem. But that's actually what makes the machine learning stuff so cool, is because coming up with manual ways to control this are kind of tough. And again, for this, you could actually probably tie this to a human model and use inverse kinematics. But there are certainly cases where you could do other things. You could move the rotation so that the elbow rotates. Something like that aren't human-type motions, and you still need to be able to learn how to control and move those types of machines. So this is a good starter problem for that kind of thing. So let's go over to Tensor Board. So I've run the training twice. The first time, well, technically 3 times, but the third time was a continuation of the second. The first one is a 5 million run, and so when I looked at that, I said, you know what, I'm looking at this cumulative reward. I didn't think we had peaked, right? It was right at 10. Looks like there's still more room to go up. So I said, all right, let's keep going. So then I did a 10 million. Yeah, so that was 5 million runs. This was 10 million runs. Got me to here, and then just because I had some little additional free time, I also did a 1 million run continuation after that, which actually didn't seem to help. Excuse me. I feel like I might need to reduce my learning rate, so I'll probably drop that and give it another try tonight, see if I can do another continuation to maybe 16 million runs, see if it'll learn and improve from there. But it did pretty good. I'm fairly happy with this. It is, it really started to plateau around 3 million, but it did get better. We're slowly getting better at 10 million, and so I do want to see how good we can get it, because there is more to learn. I do think that it could be more efficient, but we got there. Entropy didn't do anything interesting. Learning rate, nothing terribly interesting here. You can just see that if I get rid of smoothing, that I did 2 runs, right? My first 10 million and then another 1 million. And the value estimate, I think, is interesting because this is decreasing fairly steadily. So I am curious. I'm going to go back through the documentation and see if there's anything that I can do, if they have any suggestions for my correcting the fact that my value estimate is decreasing. Well, my info loss is going up. And again, when I turn off smoothing, it's a little hard to tell. You can see it, but it's a little hard to tell what's going on. So that's why I have the smoothing on these. All right, so of course we want to see what it looks like when this thing is actually running. So let me go ahead. I'm going to turn on my Academy again, so that we'll have the 1500 step max, which I've been thinking about dropping that. I'm not really sure this many steps are required, because every time that you get the target is identical, we're not building off of one another, and the environment doesn't even change, right? Because at least in the breakout one, you break a block and then the environment changes because there's not a block there. In this case, every single time you get the target, the environment is identical. Therefore, in theory, I shouldn't need as many steps in my max steps, so I should be able to train faster by having each episode be shorter. But I feel like I want to experiment with that because I might have issues with that down the road. State size is 11, action size is 5, so 1 for each degree of freedom. State size has the 5 degrees where they currently are, plus the XYZ position of the ball, the target, and the XYZ position of the hand. All right, so that was the player. And then, so I'm going to move this over to internal. And the other thing I'm going to do to make sure this is my input code, and I'm going to comment it out so that the controllers don't provide any noise to the game. One of the things that happens, you may have noticed it happened really quick though, is when I started up the game, it went to neutral position and rotated a little bit, and that was because of just where I have the default joystick positions are in relation to the game. It'll actually move the arm, which I don't want it to do that when the computer is controlling it. So I have my simple robot. It says 4 off. All of my code says 4 off because originally I thought this was going to be a 4-degree freedom robot, and then I realized how much advantage I had by adding that wrist rotate. So it's really 5 off, but all my code says 4 off. I'm going to have to refactor that at some point. And then again, for the continuous space, right, this allowed us to move it to a set of joysticks without us having to enumerate every possible combination of actions. And then here is our placeholder epsilon floating point. We got to remember to do this anytime that we move the brain to be an internal brain and that we bring in our trained machine. So this is trained actually after the 10 million. I wasn't happy with what happened when I added that 11th million, so I haven't re-exported the brain, so this is the brain at 10 million. So, alright, we're on maximize on play, and we're going to hit the play and see how it looks. So, oh, it got jammed already. Look at that. That's no fun. We're going to give it another shot. So, it does pretty good. It also gets jammed a fair amount. I'm not really sure why it's getting jammed so much. We saw this with the other bots as well, and that it would get jammed. But when I slow it down, it looks really cool, but it does get in these states where it doesn't necessarily know what to do. So I'm going to turn off maximize on play, and you'll see that if I wiggle, so we'll just wait for it to do its thing, right? So it's a little laborious, but it's going through, getting things done. It's also interesting, it usually moves with the hand bent. I hadn't noticed that. It moves with the wrist bent most of the time unless it needs to stretch it out. So it's kind of like coiled up. Okay, so it's having a really good run in this case. Yeah, it made it all the way through. So it had 17 points, which I wouldn't be able to do. And then, okay, so we've gotten stuck here. But if we move this target, I know it could hit that, right? But if we move the target a little bit, we're off to the races all of a sudden. And it jumped way up just because I was holding down the target. It does that if I do a manual adjustment. So, again, this is a case where I feel like there's a few things you can do. A moving target, see, I know it should be able to get that, but it just gets caught in these loops. So, one, I want to train it some more, drop the learning rate. I want to see if it can smooth out, get even faster, get even more efficient. But I do love, like, right there, how it just kind of reaches out to grab things. So, I think a little more training is necessary. It could be a lot more training. I also think, though, for a lot of entertainment purposes, so this isn't good enough for driving a real robot arm. I would love it if it were, because this is certainly close enough to a real robot arm. And again, it doesn't actually care how fast these speeds are. It doesn't really matter, because it's just constantly recalculating the positions. So, you can take this and you could have, specific limb rotation speeds, and it would, I think, accommodate that fairly well. So you could use this to control an actual robot arm, I think. The concern here is, though, that there's so many dead zones that you'd either have to manually look for and adjust, as a heuristic, which doesn't seem that great, or need to smooth it out or do something manual, because it does get close. Excuse me. It does get pretty close, and it is pretty good. So, and again, it's certainly way better at this game than I am. Even when I slowed it down so that it's 1/6 the speed that I am when I play, it's far superior. So. Yeah, it's just going away now. But I do like how it really does look like an arm, and it kind of reaches out. Like, it's not that hard to see. So, I had that 2 degree of freedom robot, and I did all that so that I could do this. And then I'm doing this so that I can do some other stuff, because I think there are some exciting things. So I think the next thing for me to do is look at a moving target, because I think that's something else that this would accommodate very well, so that you can see that the dead zones aren't huge, but if the robot had a moving target, it might actually accommodate that better, because the target would get out of one of these dead zones, although it seems to be zipping along. Pretty good, but not great. Right? Yeah, so could use some improvement, but I'm pretty happy with, this especially as a kind of a fun free time project. I will say, if I bring it down, right, there's that dead zone in the middle it can't get to. And then I brought it up and it was able to get to it. But yeah, so there is definitely an area in the center here that it can't reach. It's not that big, but it is definitely there. But again, when the target moves, it never spawns inside that area. It's always outside. I've never been able to get stuck in a position where it couldn't fix. See, look at that. I don't know what's going on there. But anyway, this is really exciting. It's going to be up on my GitHub page. I'll go ahead and put the links there. I just want to tweak a couple things. Oh, code. So this was an excellent opportunity for me to clean up a lot of my code. So, with so many degrees of freedom. All right, my 5 degree freedom arm, you'll see this, the hand, the hit center. And again, the hit center is for performing scoring calculations. Here are the 2 rotators and the 3 benders. So these are in order, shoulder to fingertip, and they are just arrays. And the idea here is that I make them available so that you can iterate through them, so that you can serialize all of that information for the machine learning algorithm. But this also means that we could, in theory, get as big or as crazy as we wanted by adding a whole bunch more rotators and benders. With each rotator or bender, we have a rotate script. This current rotation, desired rotation, this is just kind of some debug output for me. But I moved some of the logic, so I moved like the reset logic into each individual joint so that each joint was responsible for itself, right? So in this case, now we can just iterate through each joint, reset it, and the joint is responsible for resetting itself. And for the bend script, similar. So the bend mask, actually, what I'm doing here is I use this. I multiply out the desired or the amount of bend, and this will actually say I want to bend on the x-axis, y-axis, or z-axis. So in this case, I'm only bending on the x-axis, and I believe that is actually the case for all of my yeah, that's the case for all of my benders right now. Oh, no. Okay, so that is wrist rotate and that's wrist bend. But the ability is there to bend in other directions as well if I wanted. I just haven't needed that, but I've implemented it. And then, let's see here. Yeah, I've used rotation speeds, which is always the case now. Anything interesting? Yes. So the bend routine is in, now we pass in the parameter because we don't know how many benders we have. Same with the rotators. We figure out the delta, or desired versus current. Using the rotation speeds, I figure out what the actual delta is, and then I do this transform, rotate the delta times the bender.bend mask. I will say, though, one of the things that's very important here is I'm using bender.currentBend is a float that's attached to the bender script, not getting the rotation from the transform rotation. And the reason I'm doing that is because under the hood, Unity uses quaternions, and so what happens is sometimes the math will flip on you because of the complex component, the W. And so figuring out where exactly I was in my bend and how to gracefully go from one to another without doing kind of cartwheels through myself was a real problem. So I wanted a way to make sure that it was bending in the direction that I expected it to, and that had to do with getting the signed values that I thought I was getting. So that is why my current bend and my current rotation, both scripts have one of these, is Euler, Euler degrees, not radians, so that it's in line with what this displays, even though the values may be a little different, but then everything is in Euler degrees, and so I'm all thinking in one space instead of trying to muck with the quaternions as well as the Euler angles. So this actually, by just separating out the rotation itself and not reading from those Euler angles, saved me a bunch of headaches and fixed a lot of bugs that I was having with the quaternions, because quaternion math is not my strong suit. And I hope you'll forgive me, but I also don't really feel like quaternion math is really anybody's strong suit, except for, I'm sure, some couple of people who are awesome super wizards at it, but that ain't me. All right. Those are the major components, or the new components. Oh, one more thing, very important. Yes. Because we went up to 5 degrees of freedom, there are 5 action states, one for each bender and rotator. So in your decision script, right, so monobehavior decision, it has a default decision space of 4. If you happen to use fewer than 4, then you're fine, right? So in my previous code, because I only had 2 degrees of freedom, it had the capacity for 4 floats in this, but I was only using 2, and everything else was set to only use 2. We weren't overflowing the buffer. Everything was fine. Because I went up to 5, and I had forgotten about the script, because I hadn't touched it, I had just copied and pasted it from the boilerplate, we were overflowing. We were trying to get 5 parameters out of something that only had 4 numbers in it. So, and that was also, I didn't get any error messages in Unity. It was simply just crashing the Python side. It wouldn't connect via the network socket. So that was one that I had to find the really hard way. That was a real big pain in the butt. So that's a good one to keep in mind, that for your decide function, make sure, and you know what, I'm going to add a big thing here. Make sure this is the same size as the, what specifically do they call it? That would be the action space. I also feel like there should be some settings here. Actually, you know what? Brain parameters. Is IntelliSense up? Sometimes IntelliSense breaks. Yeah, IntelliSense is broken. I think we should see about adding a little snippet of code here that just does the sanity check. That, you know, takes in this brain parameters, assigns this float to a variable, and then just make sure that they have the same number of dimensions. Very simple check. And that could even be just an if Unity editor section of code so that it doesn't get compiled and run every single loop. But I think that is a good error check. So I'm going to see if I can add that, or if one of you feels like adding that and submitting that to the central GitHub. I would be grateful. Somebody down the line is going to be super glad that that happened, because they're going to forget to update that state space. So here it is. It's working at full speed. Again, it gets stuck every now and then. Man, that's really close. Yep, but there it is. So it gets stuck sometimes. Still, I mean, it gets stuck at 21 points, which is about 18 points more than I'd ever be able to do in that 30 seconds. So I'm very happy with it. I can't wait to show you what I'm going to do next with this. I hope you all have a good one, and happy coding.